First set of parentheses. What's the story? Okay, if you guys like, you could draw your picture. You can do the boxes if you want. Okay? So, 6 times x is 6x. 6 times that negative 4. Is that negative 24? Is everybody okay with this one? Okay, you sure?
Yes.
If you have to draw the picture. But what does this mean? Do you guys know what this means? You got this minus. What is that? There's a negative. You're right. There's a negative 1. So when you use that distributive property, it's negative 1 times what? X, which is negative x. Negative 1 times positive 2 is? Negative 2. You're right. Notice the effect. It changes the sign of both terms. They're now opposite of what they were. Okay? You guys okay with that distributive property? And again, what happens now? Combine your terms. 6x minus x. 6 apples minus an apple gives you 5 apples. If you owe $24 and then you owe another $2, you end up owing what? $26. Is that easy or hard? Easy. It's easy? For me? Well, let's see. Good examples? Uh-oh, what does that one look like?
2x minus 3x.
Who do you guys know? You got this parentheses. How do you get rid of it? Distributive property, right? Okay, so let's see. We've got to distribute this. You guys know. What's negative 3 times x? Negative 3x. What's negative 3 times positive 4? Negative what? Good. Everybody okay with that one? Now, we didn't do anything with these other terms. There's still a 2x there. There's still a minus 12 there. Okay, we just brought them down. You guys okay with that? What's in blue is the application of your distributive property. So what happens now? What do you do with this? Combine your like terms? Okay, let's see. 2 apples minus 3 apples gives you what? Do you have the apple or do you owe it? You owe it. How do you describe owing an apple? You owe an apple. Is that true?
Yes.
Minus 12 and a minus 12. Subtracting 12, subtracting 12. You owe 12 and you owe another 12. You owe what?
24.
24.
Would it be wrong if you have the 1 in front of that?
Some people will put this negative 1x. Okay? Is it wrong? No. Do you ever see it? No. Okay? It's kind of like the following. If I draw this picture and I say to you, how many people did I draw a picture of? 1. Do you guys see the number 1 anywhere?
No.
No. But it's understood as being a single what? Person. Putting that minus sign is you owe that quantity. And how much do you owe? Only what?
1.
Only 1. Okay, so you can put that negative 1 there or not. Okay, it doesn't matter. Okay, you guys okay with that? Okay, what's our time like? Good. You got 10 minutes? You got 20 minutes?
No break.
Exactly. I can't stop. I can't stop. I mean, you got to keep going till got to make up for that all that time that they give you off. Right? You got a lot of time off. Here we go, remember. We may have to, we may have to draw our boxes for this one. We may have to just take it easy and slow. Let's see. You guys know what's 2/3 times x? Is that 2/3 x? What's 2/3 times a negative 2? You guys see how all those examples that we started working with that arithmetic and fractions kind of, they show up, is that right? So what's a 2/3 times that negative 2? Positive times negative, first of all, it's negative. So we notate that the answer is going to be negative. But what's then 2/3 times 2? Is it okay if you draw this here, scratch work, 2/3 times 2? That's okay. You want to get the right answer, sometimes you have to do that. Now, you know how to multiply fractions. This is 2 over 1. Point is, what numbers are you multiplying? 2 times what? 2, and that's 4. 3 times 1 is 3. Okay, you guys okay with that? You sure? All right, here we go. What about 1/5 times x? What's that? 1/5 x, you okay? What's 1/5 times 1? 1/5. Anything times 1 is itself. So ladies and gentlemen, what you have so far then becomes 2/3 x minus 4/3, okay? Plus 1/5 x plus 1/5. Notice again the like terms. 2/3 of an apple minus 4/3 of your of money, plus 1/5 of an apple, plus 1/5 of money here. Like terms, x, money, are numbers. These terms are like. These terms are like. So notice this problem now gives you 2 fraction problems. Is that true?